Assalamu alaikum student, welcome back on my channel. And today we have very important discussion related to the our previous topic, that was Nash equilibrium. And in the Nash equilibrium we started the concept of dominant and dominated strategy, and how we can eliminate the dominated strategy to find out the dominant strategy. Okay, and we have decided that okay, now the both player or all players never play the dominated strategy, and they will try to eliminate the dominated strategy. So today, on the basis of these previous concept, I will apply to find out the Nash equilibrium and what is actually the Nash equilibrium. And first of all, student, that is very confusion about most of the students. Why that kind of the concept we apply here to find out the solutions? Because it is very important in the field of game theory. Without because if you don't have any kind of the equilibrium or the solutions, so ultimately there is not there is no way that you will not have a Nash equilibrium. Every pay of matrix always has a Nash equilibrium or the solution of Nash equilibrium. And today, first of all, we have to clear about basically what is the Nash equilibrium and how you can find it. That now here actually the Nash equilibrium is basically stability analysis. What kind of the stability analysis? If you have two player in a market, or they have any kind of the strategic environment, so that kind of the in the strategic environment they are playing their own strategy, given the condition of the other players strategy, so they always move, and this is kind of the simultaneous move game. And in that simultaneous move game we try to find out the stable solution. And in that stable solutions, both player should not have any kind of the regret कि now that strategy is not better for me, and we should have another kind of the strategy, and it will provide a better outcome. So it means that whenever we talk about the concept of the Nash equilibrium, there should not be any kind of the regret, so it is regret free decisions for individual in any strategic environment. Okay, so now let's move here. Okay, first of all, we have the example of the two payoff matrix here, and this is the payoff. In that payoff, again you have two player A and B, and similarly in that payoff matrix you have two players, but these both players have three strategies: left, center, right, and similarly up, medium, and down, and so on. In that payoff matrix, left, right, top, and bottom, and these are the numbers that associated with their profits, payoff, and utility, and whatever you can say it. So now today, first of all, we will try to find out the solution of that Nash equilibrium. Okay, how you can find out that solution? So look at the solutions and try to find out the dominant strategy here. And first of all, we consider raw player, that is actually he's A. So now look at here. So when A select decide to play top, given the condition left and right, so which one is better than for him? So now for example, so it means given the condition of left, A has two choices, top and bottom. So now it means top gives highest payoff. Look at here, the top give highest payoff as compared to 3, so we can say that the top better than bottom. Now here, clear, the top bottom then So top better than bottom. And similarly here, the right we consider is that which one when the player B decide to play right. So which one strategy is better for a top or bottom? So look at this one. So here the bottom is greater than top according on the basis of this outcome. Clear? So now here, so we can decide it that here the player A does not have any dominant strategy, because in that condition the top is better than bottom, and here the bottom is better than top. So it means player A does not have any dominant strategy. Any dominant strategy. And look at now the player B, which is the row player, sorry, which is the column player. So for the column we move here. So what about this one? So 0 and what is, so which one is better? So it means when A decide A, given the condition A selected is top, so what choice B can play? So B is better in case of right. Okay, in case of right, the B is better in case of right. So right better than left. Okay. Similarly, same kind of thing is here. So look at this one. This is for A, and look at this one. Yeah, right is better than left again. So the B, player B has dominant strategy. Player B has dominant strategy, that is what? That is uh, left. That is left. Okay. So it means look at this one. Uh, Now the 1 1, both numbers is are underlined here. We have the underline or the mark both these number 1 and 1. Okay, so this is the Nash equilibrium. Now the Nash equilibrium, although A does not have any dominant strategy. So what? Bottom and right, sorry, bottom and right Nash equilibrium. Okay, that is 1 1. Now what was our argument here? My argument was here कि whenever you have a Nash equilibrium, so that Nash equilibrium should not be a regretful outcome. Oh, okay. So what does it mean? कि यानी you don't have any kind of regret after playing these two strategies. One point is here. So whenever we look at this decision or outcomes, what is outcome? 1 1, yani bottom and right. So in that conditions, uh, individual A and B both do not have any kind of regret here. How you can justify it, or how you can check it? Okay, look at this one by one. Now, so is it regret free or regret full outcome? The question is here. Is it regret free? Regret free or regretful outcome? This is my question. Okay, so compare this one. First of all, consider this one. Okay, when we compare this outcome, because we have decided that B never play strategy L. Why the B never play strategy L? Because R is dominant strategy for player B. So now compare this one outcome. A and 0 in case of right. So now the player A is better in this position? No. So it means that there is no incentive for player A to deviate from this point. Okay, there is no incentive, right? Okay, look at from the B point. So B never play a strategy left because he knows very well what the R is dominant strategy for him. So that's why when we compare the R, so ultimately and the bottom is the best outcome given the condition that the B is playing R. So that's why it is regret free outcome. So that's why this outcome is a Nash equilibrium. Okay, when the outcome is regret free outcome, so this outcome is a Nash equilibrium. Now one point you may have in your mind, okay, means okay, when we compare the outcome of for example in case of B. So now look at this one. For A, we compare in this way. Okay, in this way. 6 or 3. Then we decide the top is better than bottom. And now here we discuss that either top or either bottom. So on the basis of bottom, is on the basis of these outcome, bottom is better than top. That's why there is no dominant strategy. So whenever you have to compare the results and outcome of for A, so we compare these values. Okay, not this one, right? Not this one. So there is no incentive for A to move here. Up now, look at this one. When we compare that outcome with this, because when we compare B, so B has two choice, left and right. Okay, so either we play left or right. So now it means that right is better. Now the left, sorry, uh, which one? Yeah, this is the payoff of this one is the payoff for B. So now the right options is better than this one. Now compare this one. Okay, the right is better than left. And similarly, when we compare here, to one is this 0. So now the right is better than this one. So ultimately, we have always play a right. Okay, now the B always play a right. So when B always play a right, so although there is no dominant strategy for A, So there is no choice for A to play what top, because on the given condition A can observe that B always play right. So there is one choice for A, that is bottom. So it means that this is the Nash equilibrium, and which is the regret free outcome. So now we can conclude that K11 is 1 1 is NE, because it is regret free, because it is regret free outcomes. Now look at this one. Okay, consider another outcomes. For example, we check this one. Now consider, now consider what? Left and top, sorry, top and left. This is 6 3. Yeah. Is it regret free or regretful outcome? Is it regret free or regretful? Yeah. Regret free or regretful? So now look at this one. So when we compare 6 and 3, clear? So now individual A is better than here in case of top. But when we compare 3 with 4 for B, because B, these are the outcome of B, 3 and 4, 6 and 3, 6 and 3 means that it is not regret free outcome for A. Okay, it is not regretful outcome for A, but it is kind of the simultaneous move game I told you. So now the 3 is not the regret free outcome for B. Okay, so now I can conclude here, although the top is regret free outcome, for A, but left is not regret free. And this is simultaneous simultaneous move game, and this is simultaneous move game. So that's why it is not the Nash equilibrium. So that's why top and left, that is equal to 6 3, not NE, Nash equilibrium. Okay, now compare 3 and 0. 3 and 0. Yeah. What about this one? Is it regret free? Now compare 3. So bottom. So now it is regretful outcome for A, because A is better than in case of top. But it is regret free outcome for B. Okay, so I can conclude that this is regret free outcome for A, but not for B. That's why, that's why it is not Nash equilibrium. And similarly, you can compare 0 and 4. 0 and 4. Again, it is not Nash equilibrium, not regret free outcome. Okay, so now we have concluded for payoff matrix 1. Okay, 1 1 is only a one solutions that represent the Nash equilibrium, and this is the stable simultaneous move game, and it is a kind of stability analysis, and we can conclude that okay, this is not the regret free, and it is the regret free outcomes. That's why 1 1 is a Nash equilibrium. Now consider the payoff matrix, this one, the payoff matrix 2. So I am going to rub these conclusion here to find out the solution of this one. Okay. Okay. Now consider this one. What we are saying. We have again two players in a market, but both players have three strategies, and again it is kind of the strategic environment, and that in that strategic environment we have to decide which one is a dominant strategy here. So now consider this one. So what, the M is better than what, L, L is better than D here. Yes, what, and they compare this one, the M better than what, U, and U equal to D, and similarly this one, what, um, yeah, and the U better than what, D, and D better than what, M. Okay, look at this one here. Which one is R is better than what, um, L, L equal to what, L better than, L better than, sorry, L better than C. Okay, this one, 4 2 1. Okay, now which one is, so here the what, 3 1 0. Okay, so C greater than what, L, L greater than R. Okay, what about this one? 2, sorry, 1 0 2. So now that this one is R better than C, and C better than what? C better than L. Okay. So now you can compare. So what you have concluded here. So just now the consider player A first. Consider A. Okay. Is there any dominant strategy for player A? Look at this one. M better than L better than D. But now the M better than U and D are equal to each other. Similarly here the U is better than D and D is better than M. So it means that there is no dominant strategy here. Just U and D are weakly dominated strategy for each other because in some case they are equal to each other. That is my conclusion. So now there is no dominant strategy for A and U and D are weakly dominant strategies for each other. Okay, look at this one. Okay, now here R is better than C and C is better than R and the R is better than C and so on. Yeah. So it means that there is no dominant strategy for player what the for player B as well. Okay. So there is no dominant strategy for player B as well. Okay. So now consider it one by one. Okay, we have to decide which one is a regret free outcome. So now there is we conclude here consider dominant strategy for B as well. Okay, B as well. Okay, so now there is the need of Nash equilibrium because if you have the dominant strategy, so every dominant strategy will be a Nash equilibrium first of all. Okay, so every dominant strategy will be a Nash equilibrium. So we have decided how you can select the dominant strategy and how you can eliminate the dominated strategy in my previous video. In this video, we have no dominant strategy for this matrix B or matrix second matrix for individual A and B as well. So now you have to decide how you will select the payoff matrix. Okay, so now here we can compare this one. What? Just we can compare. M is better than, so M is better. Okay, M is better than, uh, M is better than, yes, let me complete. Correct. UN is D. Okay. Yeah. So now here, what about this one? When B decide C, okay, which one is better then? So now I'm considering solution is here for A. Yeah. M is better than better for A given that B has left. Okay? Yeah. B has left. Okay. So now what? Look at this one. Again, the M is better than U and D. M is better for A given that B plays C. B plays C. No, not left. Yeah, left. Okay. B plays C. And again here, what? This one. U is better for A given that B plays what? Yeah, B plays R. Okay, now consider player B for player B for B. Yes, what? B, what? R is better for B when given that A plays U. R is better for A given that what? A plays A plays U. Okay. Now again the M, what one was, sorry, the C, this is for what? This one is R. Okay, what? Yeah, I'll look at this one is, sorry, this is the left. Left is better than for, not the R. It is, let me correct here. The left greater than what? C, and greater than R. So what? The C, the left is better for A. So this is the left. Okay. Now look at here. What? This one is what? The C. C is better for B given that A plays what? A's plays M. Yeah. Similarly, the last one is, so C. So this one is that. Okay. So the last one is what? Which one is the option is here? What the R is better than this one. So now this one is. So R is better for B, given that A plays what? D. Okay. So what about this one? So what the M conclusion here? Conclusion. What M and C equal to 3 and 2 is Nash equilibrium. Is Nash equilibrium. Okay, is it a regret free outcome? This is the Nash equilibrium. Is it a regret free outcome? Yeah, look at this one. For A, we will compare these number. So 3 is better than 2 and 3 is better than this 2. So now this is not the regretful outcome for A. Okay, and similarly look at this one. For B, we will compare these number. 2 is better than 1, 2 is better than 2. So it means that this is the regret free outcome for simultaneously for both player. Okay, so it is the simul- simultaneously simultaneously for both player. Okay. Okay, guys, that was from my side, and I have concluded okay, how you can find out the Nash equilibrium. And it is very that was very interesting topic, and because most of the people are confused okay, how you can find out the Nash equilibrium, and now I have explained the justification that okay, sometimes you don't have a dominant strategy solutions. So, what is the choice to find out the solution of that payoff matrix? So, it is only the one way to find out the solution of that payoff matrix, which is called Nash equilibrium, that was introduced by John Nash. He was mathematician. Clear? So, guys, that was from my side. Inshallah, hopefully, everything is cleared for you, and hopefully, we will meet in coming class soon, and we will discuss that. That was the pure strategy solution. Okay, and now I will discuss in the coming class the infinite mixed strategy solutions. And the mixed strategy solution I have discussed in my previous classes of the game theory. And in that class, in the coming class, we will focus towards that. Okay, if you will have the probabilistic scenario, and that probabilistic scenario, you don't have a single probability value for your strategy, or you, again you have the strategic kind of environment. So how you will find out the solutions through the mixed strategy or the through the probabilities in that scenario. Okay, Allah Hafiz. Inshallah, we will meet in my coming class. Thank you so much.